Okay, we're going to finish off the last of the probability topic. So the first thing we need to talk about is expectation. Basically, expectation calculates the amount that we win or lose on a game or a bet or something along those lines. So we basically sometimes call it financial expectation if we're looking at the amount of money. It also looks at the probability that something will happen over a long number of times or a lot of times that you conduct the experiment. So let's say, for example, that the probability of me choosing a green pencil out of Ty's pencil case, for example, is 3 out of 17. If everyone, 22 people in our class, has the same pencil case, which has 3 green out of 17 pencils in it, and everybody chooses one pencil, how many times do we expect a green pencil to come out? So the expectation or the probability of getting a green pencil is 3 out of 17 times the number of times the event occurs. So if we're looking to find the probability or the expectation just of the probability over lots of times, then it's the probability of the event times the number of times the experiment is conducted. For example, if we're just looking at something really simple, like the probability that a light bulb does not work is 0.036. So if, for example, a company knows that when they test a light bulb that it either does work or it doesn't work, and there's a 0.036 chance that it doesn't work, then they can anticipate that if they were to test 5,821 light bulbs, then they could expect 0.036 times 5821 to give them 209 point whatever. So they would expect that 210 of those light bulbs did not work. Sometimes if we're looking for the financial expectation, we might be looking to do in terms of how much money. So if I think of tossing 2 coins in the next example, in example number 3, so if I toss 2 coins, there are 4 outcomes. I can have a head, tail, a tail, a head then a tail, or a tail then a head. So if they're basically, I can have $5 if I get 2 heads, $1 if I get a tail and a head in any order, and I get nothing if I get 2 tails. So if I'm looking at the financial expectation of this game, then $5 times 1/4, because $5 is for 2 heads. There is 1 out of 4 chances that I will get 2 heads by tossing 2 coins, a head and a head. It only occurs once out of a total of 4 possible outcomes. I'll just draw it over here if you're not sure. So we've got a head, head, tail, head, tail. So we get head, head, tail. Sorry, that's a tail. Tail, head, and tail, tail. So one of those 4 is this outcome here, and it's $5 times 1 out of 4. Now we continue on because we want the financial expectation of the entire game. So it's $1 if we get a tail and a head in any order. So there's 1 there, there's another 1 there, so that's 2. So it's a quarter for one, a quarter for the other. That's a half in total, or 2 out of 4. So it's 1 times a half, the amount times the probability. And it's 0 times a quarter because it's 0 if we get 2 tails, and 2 tails occurs 1 out of 4. Add all of those together, press your ABC or your SD button and you'll get $1.75. So if we're looking for the financial expectation, then again it's the probability of the event, but it's times the amount that that event occurs. So basically probability times the amount, probability times the amount, probability times the amount. If it's not a financial expectation, just a normal expectation, it's just amount times probability, or the number of times the probability.